Dear students, now we are going to see the subject linear integrated circuit. The subject code is EC3451 and the topic is constant current source. On the completion of this constant current source, the students will be able to describe the frequency response, characteristics of operational amplifier working as constant current source, and explain the types of constant current sources. Constant current source. A constant current source make use of the fact that for a transistor is an active mode of operation. The collector current is relatively independent of collector voltage. The basic circuit is shown in figure and the collector characteristics of common emitter transistor is shown in figure 2. The transistor Q1 and Q2 are matched as the circuit is fabricated using IC technology. Base and emitter of Q1 and Q2 are field together, that is tied together, and thus have a same base emitter voltage. In addition, the transistor Q1 is connected as a diode by shorting its collector to base. The input current I reference flows through the diode connected to transistor Q1 and thus establish a voltage across Q1. This voltage in turn appears between the base and emitter of Q2. Since Q2 is identical to Q1, the emitter current of Q2 will be equal to the emitter current of Q1, which is approximately equal to the reference current. As long as the Q2 is maintained in the active region, its collector current is equal to the output current and this will be approximately equal to the reference current. Since the output current I0 is the reflection or the mirror of the reference current I reference, the circuit is often referred to as a current mirror. Analysis. The collector current IC1 and IC2 for the transistor Q1 and Q2 is expressed as IC1 is equal to emitted saturation current into e power VBE1 by VT. IC2 is equal to alpha into emitter saturation current e power VBE2 by VT, where IES is the reverse saturation current in emitter junction and VT is the temperature equivalent of voltage. From equation 1 and 2, VB1 equal to VB2 and IC1 is equal to IC2 is equal to collector current IC equal to output current I0. Here both the transistors are identical, so the collector current of Q1 equal to Q2. Apply the Kirchhoff's current law at the collector of Q1 that gives the reference current is equal to Q1 collector current plus Q1 base current plus Q2 base current. So reference current is also be determined by IC1 plus IC1 by beta plus IC2 by beta. So here substitute this. Combine this IC1 equal to IC2. So IC1 plus 2 IC1 by beta. So reference current is equal to VCC minus VBE on by R. So reference current is equal to IC1 plus 2 IC1 by alpha, that is beta. So I alpha into 1 plus 2 by beta. So IC1 equal to IC2 equal to the collector current IC, that is equal to the ratio of reference current by 1 plus 2 by beta, that is equal to beta divided by 2 plus beta into VCC minus VBE on by R. So output current is equal to the reference current. From equation 5, the beta by beta plus 1, the value should be greater than 1 or is almost equal to unity. The output current I0 is equal to the reference current I reference, which is for a given R1 is a constant. Typically, the output current I0 varies about 3% for the betas between 50 to 200. The circuit, however, operates as a constant current source as long as the Q2 remains in the active region. Bidler current source. The Bidler current source, which is particularly suitable for low value of current, to overcome the limitation of constant current source, connect the RE to the emitter terminal of Q2. The circuit differs from the basic current mirror only in the resistor RE that is included in the emitter lead of Q2. Due to their emitter resistance, the base emitter voltage VBE2 is less than VBE1 and consequently the current I0 is smaller than the collector current IC1. The ratio of collector current IC1 and IC2 is given by IC1 by IC2 equal to e power VBE1 minus VBE2 by VT. Taking the natural logarithm on both sides, we are getting VBE1 by VBE2 equal to KT into ln of IC1 by IC2. Writing the Kirchhoff's voltage law for a emitter base loop, base emitter voltage VBE1 equal to VBE2 plus IB2 plus IC2 into RE, or VBE1 minus VBE2 is equal to 1 by beta plus 1 into IC2 into RE. So VT ln of IC1 by IC2 equal to 1 by 1 plus beta into IC2 RE. So a relation between the collector current IC1 and the reference current I reference is obtained by writing a Kirchhoff's current law at the collector point of Q1. So reference current is equal to Q1 collector and base current plus the Q2 base current, and reference current is also be written as the Q1 collector current plus Q1 collector current by beta plus Q2 collector current by beta, neglecting IC2 by beta. So the reference current is equal to C1 into 1 plus 1 by beta. So reference current is equal to VCC minus VBE by RT. Here the beta value is always greater than 1. The reference current is equal to the collector current of transistor Q1. Wilson current source. It provides the output current I0, which is very nearly equal to the reference voltage and also exhibits a very high output resistance. Here the VBE1 is equal to VBE2 and the collector current of both the transistors are equal. Q1 and Q2 are equal, and base current is equal to IB1 is equal to IB2 is equal to IB. At node B, the emitter current IE3 equal to 2 into base current plus IC2, that is equal to 2 by beta plus 1 into IC2. IE3 is equal to IC3 plus IB3, which is equal to IC3 into 1 plus 1 by beta. From equation 1 and 2, IC3 into 1 plus 1 by beta equal to IC2 into 1 plus 2 by beta. From equation 1 and 2, we obtain that IC3 equal to I0 equal to IC2, beta plus 2 divided by beta plus 1. So IC1 is equal to beta plus 2 divided by beta plus 1, since the collector current of Q1 and Q2 are same. At node A, the reference current is equal to IC1 plus IBE3, that is equal to 1 plus beta by 2 plus beta into I0 plus I0 by beta. So reference current is equal to beta square plus 2 beta plus 2 divided by beta square plus 2 beta into I0. And reference current I reference equal to VCC minus 2 VBE by R1. And I0 minus I reference equal to 2 by beta square plus 2 beta plus 2. The I reference is very small for a modest value of beta, but the output resistance is greater than the Whittler source. Both the output resistance is greater than the Whittler source. Possible questions. What is the why is constant current source used in differential amplifier? Why is collector resistance is replaced by a constant current source in a differential amplifier? Thank you.